everyone, welcome back to Physical Science Online. This is Ms. Vukovic for the AHS Physical Science team of myself, Ms. Lackey, and Ms. Barnes. This week we are going to practice identifying different types of chemical reactions. To make it a little more fun, I decided to talk about chemical reactions in terms of food, something that you should all be aware of. And so really I just want you guys to have this understanding that there are different types of chemical reactions that are always happening, and those have different purposes. So I just want you to be able to recognize those types of reactions, and hopefully you can connect with this on a more realistic level. So last week I mentioned that there are different signs of chemical reactions. Things like bubbles being created, change in color, a smell being produced, or just a change in temperature are all signs of a chemical reaction happening. This week, we're going to look at different chemical reaction types, and the signs are still going to be the same. So, just in case you guys were getting a little bored, we're going to talk about chemical reactions in terms of food, like I already mentioned. And so whether you knew it or not, chemical reactions are involved in everything that we eat. The energy gets transformed from sun to plants. Fertilizer that gets put in the soil helps plants grow. Even the processes used to make foods, processes used to cook foods, and even the way the food changes as it cooks, all those have chemical reactions which make it possible. So how that happens is through a chemical reaction. At the end, when you're done with food or it's just getting a little bad, it starts to decompose, and that itself is also a chemical reaction. So everything that we already experience on a daily basis is just being run, or it's happening because of these chemical reactions. So there are going to be 4 types of reactions that we are going to talk about this week. I'm going to give you some background information as to how those reactions apply to food, and then I'm going to talk about the specifics of the actual reaction. So on a chemistry level, at that atomic level, what can you identify or what can you notice as key characteristics that would help you understand the type of chemical reaction? So 2 types of things are happening. We're talking about real world descriptions, and then we're also going to talk about the chemistry fundamental levels of those reactions. So hopefully we can follow along. So our first type of reaction that we're going to talk about is called a synthesis reaction. And this is a type of reaction where 2 separate entities come together to make one compound. In real life, there's a very famous synthesis reaction called the Haber process. And so in order for food to grow, something that you need to know is that seeds and plants need a compound called ammonia. Often plants will get this from soil. However, there isn't always enough naturally available for the plants to grow fast enough. So what scientists had to do is they had to invent something called fertilizer. Fertilizer is made in a lab through a revolutionary process of forcing hydrogen and nitrogen atoms together to create NH3 or ammonia. So this is a really, really famous example of a synthesis reaction, one that is using nitrogen and hydrogen to come together and make a compound of ammonia, and it's called the Haber process. When you think about the Haber process, one thing that's really neat about this chemical reaction is that it led to this invention of fertilizer, and that fertilizer helps to feed about 40% of the entire world's population. So because of this Haber process, we were able to increase fertilizer and increase the rate of which food is grown, and now feed about 40% of the world's population. This chemical reaction in science terms, which now is the cool part for me, it looks like this. So it's in the square. And you'll notice that this chemical reaction is written just like you saw last week with the element symbols, coefficients, subscripts, you have the arrows, and it looks exactly like what a chemical reaction should. However, very specific things about the Haber process and synthesis reactions as a whole are the difference in number of reactants and products. So one thing that I would do when I look at a chemical reaction is I would always find the arrows that represent where is that change actually happening? Where does the atom actually start to rearrange? And so if you look at this equation, I'm going to draw a line just to represent that there's two halves of the equation. On this side, you have your reactants, and on the other, you have your products. For a synthesis reaction, you always have two reactants and one product. So, two reactants, one product. And as you can imagine, this synthesis reaction goes from 2 to 1, and synthesis means like coming together. Coming together or synthesis. So when you guys are looking at chemistry and you have these chemical reactions being written, a synthesis reaction can be identified by looking at the two sides of the arrows, your reactant and your product side, and counting how many reactants do you have and how many products do you have. That's how you will identify that synthesis reaction. Another type of reaction that happens all the time and we can identify and talk about in chemistry terms is a combustion reaction. So in terms of food, whether you're outside grilling or you're inside using the stove, odds are that you guys are going to be using fire to cook food. And you knew that. Like if you've ever roasted marshmallows, you know that fire can cook food. But something that we never really ask ourselves is how do we actually make fire? Like what's happening that is making this fire? And one of the things that you should know is that you can only make fire or light a match if you have oxygen. So that's the theory behind combustion reactions, is that you always need oxygen present. A fun history fact or background information about fire and making fire more accessible is the invention of a match. John Walker was the first person to invent the match in 1827, a long time ago, almost 200 years ago. People were really excited about it because making fire is something that you and I probably take for granted, but back then it wasn't very easy. So anyways, he had that stick and you would strike it against something and you would make a flame. What's happening when you strike a match is this reaction. So when you actually strike a match, what's happening is these hydrocarbons in the match react with the oxygen in the air, and they react so quickly that they create this carbon dioxide and water as a byproduct, so as their product. Hydrocarbons aren't really something that we need to know much about, but it's really just a hydrogen and a carbon together. And if you look here, one of the neat things is that the wax on top of your match, so on top of the match, is a hydrocarbon. So that's what's actually reacting on top of your matches to make that initial flame. When we look at combustion reactions and we're trying to identify them as a combustion reaction, the key trait that you want to look for is on the reactant side. So again, if I draw an arrow down the middle where that arrow is, or if I draw a line down the middle where the arrow is, and I separate our reactants and our products, on our reactant side, the big thing that makes this a combustion reaction is O2. So oxygen being present on the reactant side is a key indicator that you are looking at a combustion reaction. Sorry about my dogs. A squirrel is crawling by the window and they're crazy. Anywho, when you're looking at a chemical reaction and you divide it in between reactants and products, if you look on the reactant side and you see oxygen, and then if you look on the product side and you see water, those are two clear indicators that this is a combustion reaction. Fire is being made. So what I'm trying to emphasize is that you need to recognize this portion of a chemical reaction written out, so that chemical equation, and then you want to be able to identify the type. And so my trick is divide it between reactants and products and find those key characteristics. Our third type of reaction that we're going to learn to identify is called a replacement reaction. When you look at the chemical equation of a replacement reaction, it can be kind of tricky. Replacement reactions can be single or double, meaning there's two different levels of complexity to them. And because they're complex, they actually in real life end up having some cool effects. So the product of a double replacement or a single replacement reaction end up being pretty neat. One of the coolest reactions, I think, is something called the Maillard reaction. And it's based on this idea that when you cook food, it tends to brown. So if you've ever cooked food with heat, you've noticed, like, even if it's cookies, the cookies, like the bottom of a cookie might turn brown, or if you grill a steak, like that ends up turning brown. Scientists noticed that, or they made that observation that, okay, when you cook food, it turns brown. And somebody named Maillard determined all of the chemical reactions that take place to make that happen. And that's why it's called the Maillard reaction. Anyways, what happens though when you have your food cooking and you notice it starting to turn brown is that sugars and proteins in the food, and then like also any excess water, they all start to rearrange. So all the elements that make up those sugars or those proteins in that food, those elements start to rearrange and they end up making flavors. So when that sugar starts to rearrange with the protein, they trade parts, kind of is what's happening. And you end up with those flavors, which is a great thing for us. In addition to having those flavors, one of the really cool indications of the Maillard reactions is the fact that it's turning brown, that food turns brown. And when food turns brown, we know that that's a color change, which is an indication of a chemical reaction. So to get into the science of the Maillard reaction would be a little daunting for us. Really what we know about those reactions is that when you're cooking food, rearrangement of amino acids, which are parts of proteins, happens. So amino acids start to rearrange, and in the end, you end up with these different sugars or proteins, and that's flavor. If you really wanted to become like an amazing chef, you can look up Maillard reaction, and there's many tips on how to cook food and what the correct temperature is to cook food at. So if you're really interested into cooking, this is a really fun reaction. On our level of chemistry, when we look at a chemical formula or a chemical equation, we want to be able to identify where we have compounds and where we have just elements on both the reaction and product side. So like I've done with the last equations, I'm going to draw a line to separate our reactants and our products. When you separate reactants and products, what you will look for are the rearrangement of the shapes or the rearrangement of compounds and elements. Notice on the reactant side, you have an AB compound and a C element. A key thing to these replacement reactions is that this is going to change. So if this is AB, on the product side, it can't still be AB. Instead, what you have is BC. So the B stayed the same, but what happened is the C and the A switched. It's tricky, but you are really just looking for that change in combinations. So what I would do is look for your compound. We know that our compound is AB. Find the compound on the product side, and it's BC. And because those aren't the same, you know that it's going to be a replacement reaction. There are other ways you could go about this. You could look at just simply your single element in the reaction and notice that it changes. But I like to pay attention to the compound because that's the most complex part. So if the compound ever changes between the reactant and the product side just by one letter, then you know you have a replacement reaction. Okay? All right, our fourth and last type of reaction is called a decomposition reaction. Many of us are already aware of what a decomposition reaction is because we know it's when things break down. In terms of food, decomposition reactions are happening all the time. Food was once alive if you think about like meat or veggies or fruits. Those were all once alive when they were attached to its original source. But now that we've taken them away from that, they don't have all the nutrients to keep up those chemical reactions that are essential for life. So what starts happening is they break down. If you've ever gone to your refrigerator and opened it up, you might notice that sometimes your fridge starts to smell. You might notice that your fridge starts to smell when food goes bad. And if you were anything like me, you might smell the food or check the expiration date to see if you should actually eat it. When you're doing that, what you're checking for is to see if that food has started to decompose. A lot of us have a tendency to decide, okay, it's past the expiration date, we're going to throw it in the trash. But what you can also do is take your food scraps and put it into something called a compost where it will decompose naturally and it's going to break down into simpler parts. I'm going to apologize right now because I have no idea what happened right here, but I think I was supposed to say, have you ever heard of a compost? I don't know, y'all. Week 6 and it's getting a little crazy, and I apologize. So a compost is a method for encouraging food to break down naturally without sending it to a landfill. And it just takes organic material, which is food, and it breaks it down to small parts where it can be applied to the environment. It helps reduce waste for households, and it's really a great tool for if you're looking to do something like environmentally friendly. Composting is something that's kind of easy, but just takes a little bit of money to get started. So composts are really cool because that's decomposition happening right there. It's an easy way to encourage decomposition naturally and not just send things to the landfill. In chemistry terms, decomposition reactions are written in the same type of chemical reaction equation that we've been seeing since last week. Just like all the other reactions, what you want to do when you see a chemical equation is draw a line down that arrow so you can separate the reactants and your products. The difference with a decomposition reaction is when you look on the reactant side, what you're going to see is one compound. So you're going to see one compound. And on your product side, what you end up seeing is that one compound broken apart, so split into two elements. Again, it's not just the atoms that you're looking for. You're looking to see if they're together, like on the reactant side, and then on the product side, they're separated. So if you're struggling with that, like looking for compounds, you can also do another trick. You can draw the line down the middle, separate your reactants and products, and then what you can do is look for the presence of a plus sign. On your reactant side for decomposition, there's no plus sign. So that's 1. That means like there's nothing being added together, there's just one thing present. On the product side, you do have a plus sign, and so that means that you have two separate entities. Two things are being added together. So again, it doesn't really matter which way you look at it, but you want to make sure you recognize for a decomposition reaction, the reactants that you start with are complex. The products you end up with are pretty simple. All right, so that's all for this week. I hope you enjoyed learning some more real life applications and learning about chemical reactions and different types of it with examples, always related to food. It's always a good idea. For this week's activity, you're going to find that there is a worksheet that you're just going to make a copy of and type your answers into. You will then have to turn that into Google Classroom, and do not forget to submit it because I won't know if you submit it unless you do that. So attach it to your Google Classroom assignment and then just click turn it. All right, well, I hope you guys had a great week. Email me if you have any questions. Always feel free to research or fact check any of the information I presented today. But I hope you guys have a great week and eat something good. Talk to you soon.